Hello and welcome to the first of many video lectures of our notes in AP Human Geography. Our first chapter, Key Issue 1, is the key issue is why is geography a science? So let's begin. So first of all, we're going to learn a little bit about maps today. We're going to talk a little bit about some of the things that make geography, right? So two questions we ask are why and where. So sometimes we call geography the why of where, right? The word traces back, the origin of the word geography traces back to Eratosthenes back in the day. He's a Greek. We look at two major divisions. Last year's class had more of a physical geography nature, in which you had natural forces, things like climates, volcanoes, vegetation. This year's class is going to be a little bit more human-based, in that we will talk about climate, volcanoes, and vegetation, but only as they relate to humans in terms of population and why things are where they are. So human geography, things we're going to be looking at are population, migration, religion, languages, some cultural geography there, and also economic geography. Some basic concepts that you're going to be learning in this class and throughout these chapters, and particularly chapter 1. We're going to look at how to identify the location of important places. So things like site and situation are going to play into these conversations. We're going to explain why one human activity is found near another. We're going to ask why and where things are. Why are things where they are? We're going to learn about organizing materials spatially. Right? And then we're also going to understand the concept of recognizing that an action at one point in the Earth can result from actions at another point, which can consequently affect conditions elsewhere. So we're going to look globally. We're going to look at locally, and we're going to be looking at it on a national scale, many different scales as we go through. All right, so the next couple slides you aren't going to see in your book, right? Our book is good. It is brand new, so it's not as outdated as we'd say, but there are some things that it does not cover. Things that appear on the AP exam or may appear on the AP exam. So you're going to see some of these in your vocabulary sheets. You're going to see some of these others. I'd invite you to take pictures, of these slides with your iPads, because that's what many students do, and then you have them kind of tucked away. All right, so first thing we're going to talk about that isn't in the book are the 5 themes of geography. This used to be the way that we taught geography. It was created by the National Geographic Society, kind of a big deal at National Geographic, back in the 90s, right? And it basically looked at everything or every place from 5 themes, right? First one was location, where is it? Second one is region, but what places does it also have traits in common with? You had a sense of place. You had a sense of human environmental interaction, or HEI, in terms of how it impacts an area. It's more of a cultural landscape piece. And then we also had movement, right? Movement of things, ideas, and people from place to place. All right, basic concepts of maps. First thing you should know is the word cartography, which is the science or the art of map making. We understand that maps are scale models of the real world, and there are 2 main purposes of maps. One, to use as a reference tool. You would refer to it in how to get from A to B. So a treasure map would be a good example of that. A road map would be a good example of that. The maps that you see in terms of your phone, on your phone, would be the purpose of maps, right? The second way to purpose of maps is as a communication tool. Right, and it's going to explain why things are where they are, or where things are located. So if we look at this is a map as a reference tool, right? This is the Twin Cities metro area, and if you are over on 394 and the Olson Memorial Parkway, and you're looking to get to Woodland, this map would help you get there. You would refer to it to get you over to Grays Bay over yonder, right? This one also covers the Twin Cities metro area, but it would not help you get from A to B. There are no roads on it. You wouldn't refer to it, but it does help you understand where populations are in terms of immigrant populations through the use of language, right? The second most common language spoken at home within area school districts. So we're looking at a younger population. Again, you wouldn't use this to get from A to B, but you would use it to disseminate. You would use it as a communications tool. All right, so we'll look at our first maps, a brief history of map making. We look at the first ones being 700 to 600 BCE. We give the Greeks a lot of credit here. You got Aristotle, who comes up with the spherical Earth. You get Eratosthenes, who understands the Earth's circumference. He's comes up with an early climate map. You get Ptolemy, who's a Roman, who is more of a compiler of laws, but also he compiles maps, right? He is our information gatherer of that era, right? Keep in mind, though, that we like to think in Eurocentric terms a lot, especially in our textbooks, but that there are a ton of other things going on, and we look at different ideas, right? That the Chinese dynastic China has famous cartographers or geographers in Fei Shui, right? And you have in the Muslim world, right? You have Ibn Battuta, which I probably didn't say that right, but I'm going to do the best I can here. So when Europe goes into the Dark Ages, it's not like map making stopped. Things were going on well outside of Europe. Right? We do see a resurgence in map making in Europe during the Age of Exploration. You have people like Columbus, who needed maps, Magellan, right, who was the first to navigate the globe. You have a guy named Mercator, who comes up with the Mercator map projection, right? And then you have a guy named Vespucci, who his first name was Amerigo, for which we get the name America, as in North and South. So there's the world map drawn by Eratosthenes in 194. Certainly not a complete map, but it is what he knew at the time. All right, there's a world map in 1571. Also not a very complete map, but as we gain exploration, we see that things get a little bit tighter. All right, the modern geography. The modern tools aren't necessarily people drawing maps. It's done computer based, and we look at GIS science. Right. So 3 different things that you want to know there is GPS, global positioning systems, and that's where information is shot up to satellites. It's generally not all 24 of the military satellites, but then the location is then pinpointed. The information is shot back down. You can get very, very technical and very, very close to exactly where you are by using GPS, right? Commonly used for navigation, right? This is your GPS. This is what you have on your phone. This is what you have in your car, that type of thing. Can also be used for recreation, like geocaching, things like that. And can also be used to find the latitude and longitude. Not that people use that a whole lot to describe their location. The speed of something that's moving, the elevation of a place, and the direction that you are going. Right? The second way that we look at this is something called remote sensing, and that is satellite-based mapping. And instead of things being shot up to satellites and things like that, we see high airplanes or satellites taking pictures, right, from space. So you're going to see weather patterns are all going to be, that's going to be remote sensing. You're going to see anytime you see the Pentagon or kind of spying on other countries, or terrorist camps or things like that. That's going to be remote sensing. And then our third and probably the most important of these 3 is geographic information systems, right? GIS, and these are computerized mappings, and they are layered, right? So you take a layer that is the dirt, right? And then you put the roads over it, and then you put the businesses over it, and you put all of those things in layer after layer after layer, right? And you can get some very sophisticated, very specific maps from that. All right. We also look at VGI, Voluntary Geographic Information Systems, and we think in terms of a mashup, which is kind of putting things together. It's a hip hop term actually. And then Google Earth is our low-level GIS. All right. So there's GPS. And here is remote sensing. And here is GIS. Notice the layers, right? Here's layer 1, and then you have the highway vector, and then you have the landforms, and then you have all of this combined, right? And you can take things out and put things in and mash them up that way. Okay, keep in mind electronic navigation is another word that we use. We look at the Google car, right? You've probably seen the Google car at least once driving around. Right? Usually it's done in pairs. There's one driver, there's one observer, and this is how things are updated. This is how information gets updated because our landscape is constantly changing, right? Our Perkins is no longer our Perkins. It is now the Mexican restaurant, and so now that needs to be updated. All right. Very important concept here, the idea of scale, map scale. The definition of scale is the relationship between the size on the map and the size on the Earth. And it impacts level of detail and area covered. Those are the two things it covers, right? The amount of detail and the amount of area. Pretty important to remember, right? We can express it 3 different ways. You see ratio there, you see it can be written, and then you can see the graphic, right, as well. This to here is 1,000 feet in that particular ratio. All right, understanding what a small scale and a large scale map is, right, is pretty important. And this gets a little confusing because we tend to think of large maps that covers a large amount of area as being a large scale, but it's actually the opposite, right? A large scale map shows greater detail over a small area. So your neighborhood map would have plenty of detail. You could see trees and you could see garages and you can see all of these things if you scale, right, and if you do a large scale map. That neighborhood is also on a map of the Earth. You just can't see it because a small scale map shows less detail over a large amount of area. So going from here, my yard, this would be a large scale map. The further out you go, right, the smaller the scale it gets. Now remember, if you look at this graphic, right, a ratio is a fraction, right? So if this particular map is a 1 to 15,000 ratio, if it were blown up 15,000 times, it would cover the same amount of area as whatever you were mapping, right? Which isn't very functional because you need it to be smaller so you can manipulate it. All right, so here we go. We have a small scale map of Texas and Louisiana. Note the ratio, 1 to 10 million. All right. Now we have the Houston metro area. Okay. Again, note the ratio, 1 to 1 million. So this is 10 times larger. Okay. We see central Houston at 1 to 100,000. Notice the detail. All of a sudden you can see the roads a little bit better than here. You can see buildings. And you really look like you're flying over it, right after you've gone out of the Houston airport. Right? And here is a 1 to 10,000 ratio where you have Minute Maid Park, home of the cheating Houston Astros. All right? So, question, which one has the larger scale? Is it the left-hand one, where you see Park High School, or is it the right-hand one where, oh, there is Park High School on there, you just can't see it. So which one has the larger scale? It would be this one, large scale, large amount of detail, but it only covers a small amount of area. Right? Projection is our next big concept that we need to talk about. Projection, right? Remember, the only true accurate model of Earth is a globe, a three-dimensional product. Three-dimensional thing being represented by another three-dimensional thing. If you move a three-dimensional thing to a two-dimensional thing like a map, you are going to get some distortion. So globes don't distort, but all maps have some sort of distortion. And it can distort a couple different ways: size, distance, shape, and direction. All right, we look at different projection types, how this is how these are projected. So we have cylindrical, which looks like a cylinder, planar, which looks like a kind of a flat sheet of paper, conic, which looks like a cone, right? And then an oval. So think of these as you're trying to wrap your map around a globe. All right, so there's your cylindrical. You might want to wrap your globe around like a cylinder, right? The problem with that is, again, you are going to see on a Mercator map, you're going to see major distortion at the poles, right? Conic, you have this. You're not going to see a lot of conic. You're going to see these really on the poles as well. Same with planar. All right, so if we look at distortion, if you look at the size of the Mercator projection, look at the size of Africa and look at the size of Africa in compared to Europe, right, in the Gauls Peter, you see a big difference, right? So keep in mind that maps and the projection of maps can be used for political purposes, right? So people were in Europe were hard pressed to get rid of the Mercator map when they were trying to explain things because it made Africa look big, smaller, and it made Europe look bigger, right? And it was pretty easy then it was an easier justification for colonization. Notice that we have other types here. We have the goods homoselene. You're going to see a lot of goods homoselene. It looks like your little cousin got after it with a pair of safety scissors. But what it does is it cuts out all the unpopulated areas. So it's a good projection for what we're looking at in human geography when we're looking at that. You have a Robinson map right in here, which is kind of a split the difference. It's a map. It is distorted in all four of the different types in terms of shape and size and direction. But it doesn't necessarily do a whole lot of it. So it's in kind of it's a good compromise map. All right, there's the Mercator projection. Note the distortion at the bottom. All right, there's the goods homoselene. Here's the Robinson projection. All right, and then we look at the geographic grid. Right, so we're trying to answer what are the coordinates. Right, we look at absolute location. This is absolute. We can change the way we talk about place in terms of names changes and site and situation will change, but absolute location does not change. We look at a system of meridians and parallels, right? 0 degrees to on the equator, and then also the prime meridian, which runs through Greenwich, England, right in here. We look at latitude and longitude. Latitude measures degrees north and south, right? They run east and west. They run this way, but they're measuring north and south, right? And they look like ladders. Latitude, ladder, right? There's your mnemonic device. Longitude goes 0 to 180 all the way around, halfway around the world from Greenwich, right? So you have the eastern hemisphere and then you have the western hemisphere. Actually, this would be the western hemisphere. Right, and then the east goes all the way around. 180 plus 180 is 360, which is a circular, right? All the degrees in there. And again, we look at astronomy, right, and time and how these were determined. Right. Last thing we're going to talk about today is types of maps, right? And these are the most important tool for geographers. You're going to be seeing a lot of maps throughout your time in geography. So it's important to know a little bit about each time. Thing, right? First of all, we got the reference map. We're going to look at a choropleth, a dot, a graduated symbol, cartograms, topographic maps, and an isoline map. As you go through each one of these, note how does it explain things? What is it using, right? So if you can, in your mind, being like, okay, this is what it does and how it does it. So think about how it explains things. There's your reference map, right? You would refer to it. This is your United States. Note that there are highways here. You would refer to it to get from A to B, right? Here is a choropleth map. And a choropleth map measures the amount of something in a given area by shade, right? Generally speaking, the darker the shade, the more of whatever we're talking about is involved in that area, right? So here we're looking at turkeys and we see that Minnesota leads the nation in turkeys raised, where we have the darkest piece here, right? Whereas others like Texas and New Mexico only have 3 million. We see North Carolina and Arkansas being kind of in that second tier. We see Missouri and Virginia and Indiana being in that third tier, and it goes lighter, right? So generally there's a color scheme here. We got a brown here, right? We go from kind of a grayish brown all the way to a dark brown. It doesn't have to be that way, but it is the most effective if you use a color scheme. Right, there's a dot map. We're looking at the number of cows, right? And we can see cows in here in Wisconsin are America's dairyland, but we also see it here. And this explains where cows are. It does not explain why cows are distributed, why you see dots in all 50 states. I guess maybe you don't see it in Alaska, but there's even a dot in Hawaii, right? And we need to think about how and why in terms of spoilage, right? That's not on the map. That doesn't tell you why, but it does tell you where, right? And remember, back to dot maps, that every dot here is 2,000 milk cows, right? So it gives you a good idea in terms of how things are being done. Like one dot equals X amount. Go from there. Keep in mind that when one dot changes, and you're going to see this when we talk later on, it can really give you, if you look at two different maps and one dot equals a different thing, it can be a little bit confusing. All right, oil consumption per state. Again, we look at barrels per year. You see a dot symbol map here, right? One dot is smaller, right? And then it gets bigger. So that's a bit more of a graduated piece here. Here's a cartogram. Cartograms take the shape of whatever's going on, but it changes the size based on whatever we're talking about. And here we are talking about the population in 2002. Now this has changed a bit, but I have not been able to find a better one than this, right? If you look at India and China, they are massive compared to the actual landmass. So it's taking away the landmass, right? But you look at places like Mongolia, which is tiny, Russia, which should cover all of this. Canada looks like a top hat on top of the United States, right? And those are places that have small population density. Pakistan, Bangladesh, Japan, the Korean Peninsula are bloated, right? They're very big. Right? If you look at other places, though, like Canada and Mongolia, you'll see that they are very small. And Australia is a great example of that. You have Indonesia, right? All those islands above it, but Australia is massive, but it does not have a massive population, and that's what it's measuring. Topographic maps measure elevation, right? The topography of a place. I know we're Minnesotans, we don't have a lot of topography around here, but if you head out west, you'll see, you get into a mountainous area, you're going to see more topographic maps, and they tend to be, every line is going to be 10 feet up or 10 feet down, or something along those lines, right? And here's isosline maps where they use lines. You'll see this in weather a lot. As weather patterns move through, you'll see isosline maps in terms of the temperature, being lighter to hot or something along those lines. Note that they use color, right, to distinguish between things, but they also use lines as well. And there you have it.